Alright folks, today is day one of graphing rational functions. Okay, we're going to actually begin with some review of factoring, which is going to be helpful when we look at the equations of some of these functions. So, to start out with, when you're trying to factor something, you want to always look for a GCF. After that, we're determining whether there are two terms or three terms to know the process next. So with the first example here, there's not a GCF between these two, but both the first term and the last term here are perfect squares, so this is a difference of squares. In general, when we're talking about factoring, we usually start out by setting two sets of parentheses equal to 0. And with the difference of squares, all we have to deal with are the square roots. So the square root of 4x squared is 2x. That'll go in the first spot of both of those sets of parentheses. And then the square root of 9 is 3. But really we want to get to a negative 9, which means we need one positive and one negative. Okay, when you're factoring, you can always check yourself by distributing back. So 2x times 2x gets you 4x squared, that's good. Then the outer and the inner, okay, we've got a negative 6x and a positive 6x, those cancel. We didn't have a middle term, so that's good news. And then positive 3 times negative 3 to get negative 9. When you're solving, you're just setting each of these equal to 0 separately. So our first answer, if we want to get x by itself, we'll subtract the 3 and divide by 2. Second answer, we'll add the 3 over, divide by 2. So we've got a positive and a negative 3/2. The second one also has two terms, but this time there is a GCF, and that is x. We can pull that out of both terms, leaving x minus 8. So then our two answers for this one, first term is just 0. Second term, add the 8 over to get 8. When there are three terms, we're still looking for a GCF first, but once that's taken care of, you want to look at the a value, or the coefficient in front of your square term. If that a value is 1, you can start out by always just putting x times x to get you to x squared. Then you're looking at the factors of the c term, or the last part, and we want to look at the factors of 35 that would combine to be a negative 2. So the negative here tells me that I need one positive, one negative to multiply to be a negative 35. And when I combine these, I have to have really a difference of 2. So my factors that are going to work for me are 7 and 5. But to make this actually a negative 2, that 7 has to get the negative. Okay, so plus 5 and minus 7 for that one. So then, we just have to solve like we have been doing. First one subtracting the 5, second one adding the 7 to get negative 5 and positive 7. The last two we have to do frowning face factoring for, because the a value is not 1 and there's not a GCF. So we're taking 3 times 8 to get to 24, and we're still looking at the factors that can add to, this time, a negative 14. So 24, we can use 2 and 12. If I need a negative 14, I need negative on both of these, that way I'm multiplying to be a positive still. Okay. In Algebra 2, you learned that these factors you can split here and say 3x squared, then minus 2x minus 12x plus 8 equals 0, and then factor each side. So in this first part, you can pull out an x, and you're left with 3x minus 2. The second part, you can pull out a negative 4, and you're also left with 3x minus 2. Last step, we can regroup because a 3x minus 2 shows up in both of those terms, and we are left with x minus 4. I am going to show you one more way that we can do this using these same factors, or the same first step. The whole process for most of these, with the exception of this weird second one, is we started out with two sets of parentheses equal to 0. And the reason this wasn't easy factoring, where I could put an x and an x in there, is because this 3 was in the way. So what we can do is actually divide away the 3 on both of our factors and go ahead and use the x and the x. So here it'd be minus 2/3. This can reduce, and it's minus 4. And then the only thing we really need to do here is get rid of this fraction by multiplying that denominator through to get 3x minus 2. And then, if you'll notice, we get the same thing as we did down here. And I think it becomes a little bit faster of a process, okay, but you're welcome to use either method for today. Either way, we're getting a positive 2/3 and a positive 4 for our final answers. Okay, so what I want you to do real quick is pause the video and try to factor this last one just on a piece of scratch paper, please. We're looking at the factors of a -6, so for us that would be opposite signs, so positive 6 and a -1 to make that 5 happen. And then I'm going to divide away the a value, so then I have x plus 3 and x minus 1/2, but I do need to fix this by multiplying by that denominator, which comes up with 2x minus 1 for my factored form. Then my 2x values are -3 and positive 1/2 to finish out there. Okay, that's going to help us with what we're doing today. On your practice, you have 2 examples of graphs, and what I want you to do is pause the video and write down every single thing that you notice about the graph. Okay, so that could be your critical points, any features that you think are important, domain, range, whatever you see. Okay, pause the video and write those down for me, please. So I mentioned asymptotes. There's a horizontal and a vertical one. The horizontal one is at y equals 1. The vertical one is at x equals 1 as well. We do have 2 intercepts here. They're marked. The x-intercept is at -2, and the y-intercept is at -2 as well, which would make our domain -∞ to 1, union 1 to infinity. And our range would be very similar because we also had an asymptote at 1 for those values. Okay, but you'll see below that I have an equation written here, and I want to talk about where these things come from dealing with the equation. That's the whole goal of today, is to notice the patterns to tie the algebraic parts of the function to the graph. So if you'll notice, this x minus 1 is on the bottom, and that directly ties to the vertical asymptote. Okay, because vertical asymptotes are by definition restrictions in the domain, and they tell us what x values don't work. So if I plug in a 1 here, I get 1 minus 1 is 0. That's a problem because we can never divide by 0. Okay, so vertical asymptote is directly tied to the denominator, what causes it to be 0. Okay, the x-intercept is actually tied to the numerator, not directly, but with the math that is used to solve for it. If you look here, the y gets to be 0 for an x-intercept, so if I substitute in 0 equals x plus 2 over x minus 1, in order to solve for this, I need to get rid of that denominator, or multiply by it on both sides. And then over here, you just get 0 equals x plus 2. And so I really only have to deal with the numerator here, and it's the opposite sign when you go solve for x. The y-intercept is similar in terms of the process. We just look at where the 0 is. This time the 0 goes in for x, so we're putting a 0 there and a 0 there, and we're left with 2 on top and -1 on the bottom, and that's where the -2 comes from. Now, the last one, I kind of left the horizontal asymptote for last on purpose, because it's a little bit more challenging to see where it comes from. What I want you to do is actually find all of the things you notice about the second graph, and then we'll kind of go through those here after you've written those things down. Okay, so pause the video now and write down all of those important features for this graph. Okay, we have a horizontal asymptote this time at 2. Vertical is at -1. X-intercept looks like it's at 1/2. So negative 1/2, 0. Y-intercept at 1. Domain is everything but the vertical asymptote. And range is everything but the horizontal asymptote. Okay? Well, here, if I kind of want to use the things that we learned last time, we can write an equation based on those patterns that we saw. Okay, so I'm going to flash back here again to just show you on the last equation. Remember, the denominator dealt with the vertical asymptote. The numerator dealt with the x-intercept, and then kind of on the edge here was your y-intercept. Again, we'll talk about that horizontal asymptote here in a bit, but what I want you to do is, based on that information, try to write an equation from the x-intercept, vertical asymptote,